Welcome back to the Automation Podcast. My name is Shawn from Insights in Automation. And in this episode of the show, I meet up with Kelly Passineau from Rockwell Automation to learn all about a brand new product they're launching this week. It's an Ethernet IP in-cabinet solution. It's phenomenal. The amount of wiring it's going to reduce if you use it is amazing. I think you guys are going to really enjoy this. Now, if you do, or if you have any questions or any thoughts about this, please leave them in the comments. Whether you're watching on YouTube or listening on iTunes, Spotify, or somewhere else, or at theautomationblog.com, I'd love to know what you guys think about this. I'm pretty excited about it. And for you members out there, I'm actually going to include some bonus video and some additional thoughts of my own in an after show just for members. So with that said, let's get to this week's episode with Kelly Passineau from Rockwell Automation. Kelly, thank you for coming on the Automation Podcast. I am excited to learn all about this Ethernet IP in-cabinet solution. But before we jump into your presentation, could you first tell the audience who you are?
Hey, Shawn. Well, I am Kelly Passineau. I am here at Rockwell. I am our product manager, global product manager for this new product, Ethernet IP in-cabinet. Been with Rockwell for a number of years in a lot of different roles, and most recently going to lead this product to market. So we're super excited because we just went to AFC and we are available for sale this week. So super excited. So I thought we would jump through a few slides and we'll see what kind of questions we can help answer. So Shawn, we kind of opened up and we talked about this being this thing called Ethernet IP in cabinet. And so in a sense, we're not, think about it, we're not really introducing a brand new network to the market, right? We here at Rockwell, we currently have Ethernet IP. That's our mainstream communication platform. This is really an extension to that network. What's really cool is, and this kind of goes back. If you look at it, this starts kind of back at, way back in I think about 2019 with IEEE, and so we're going to be leveraging an IEEE 802 single pair Ethernet design. All right. So this is kind of a brand new technology for us. It's IEEE standard for the T1S protocol for single pair Ethernet, 10 megabaud. And what you're seeing or what you're viewing here is really it's our adoption with ODVA. So when IEEE launched out this specification, we began working with the ODVA organization to try to figure out how do we implement this for industrial control cabinet designs. How do we expand the number of nodes, the connections, and bringing that into the Ethernet IP protocol. And hence, that's kind of exactly where we're at today with launching the in-cabinet solution. So just to give you a little bit of background, kind of where the organization's and when that started. So if we kind of look at what we're doing with this is an opportunity to kind of change the game. Today, our customers connect our industrial components, and we've been selling industrial components for a very long time, and we continue to sell components. And these components would mount in a control panel, and they get hardwired. That's how we traditionally connect our products. They're all hardwired designs, and typically they get interfaced into PLC I/O cards, right? Inputs, outputs, right? All those control. When you build a control panel, you take a series of logical inputs, you create a program, and there's logical outputs, right? There's nothing too mysterious about that. We've been doing it for an awful long time. And but what we know with doing wiring, we know that it can take a long time. It's time consuming. On average, it takes about 6 minutes of wire to terminate. When you think about it, 6 minutes of wire. There's two sides of a cable, 6 minutes, and by the time you cut, strip, mark, and terminate a wire, that adds up. And when you start looking at a control panel where you have several hundreds of wires, that begins to lead to things: one, time; two, maintaining and troubleshooting and testing. So what we're trying to do as we launch out this new technology is an opportunity to start to focus on those things. How do we help our customers reduce those number of pain points, right?
You
How do
know,
we make it easier to install?
I just want to jump in. I know a lot of us spend so much of our time programming, designing, and we're not out there wiring the panels. But, I was reminded of this last summer when I had to build 6 test stands and
Oh yeah,
hundreds and hundreds of wires. And I pulled a couple all-nighters to have this thing done on time. And so it just blew my mind. Like you're saying, 6 minutes per wire. It just blew
minutes.
my mind that, everything goes in opposing terminal blocks, right? And so
Yes, yeah,
it blew my mind. It is truly, if you have not wired audience, if you haven't wired a panel in a while, or had to, troubleshoot or test it to make sure all the wires go to the right place, I consider myself in my old age a very good panel wiring person, but I made mistakes. You got hundreds of wires. The chances are you will make a mistake unless you're doing this every day. So I really hear what you're saying there, and I'm excited because this is an implementation. When you first said single pair Ethernet to me, this was not what I was thinking. So I'm excited to hear more about how your implementation of this is going to
yeah,
drastically reduce the wiring time in these panels. And for those who are not watching, if you're listening, I know a lot of you listen only. We had a panel here where a gentleman's wiring it up, and there's hundreds of wires there, and it's just
yeah.
lots of times doing it the classic way that most people do it today. So, Kelly, let me turn it back to you. I just wanted to throw that out there.
Yeah, sure. Well, Shawn, you bring up a great point. I think it's something that we don't really think about. I think we've been wiring products for so long, and it's just something we do. But when you really begin to look at the landed, how many minutes it takes and how many physical point-to-point wires there are in a control system, it certainly can be a little unyielding, and it adds up. And then the problem is the customers, they need changes, right? It's like, oh shoot, we should have added just one more motor starter, or we should have added this light instead of that, or this controller instead of that. And when you get into those situations where we're hardwired, those get complicated, right? That complicates things, right? Now you got to figure out, you got to design it differently, you got to change it. Might have to change the layout, right? Now you're certainly wiring more devices, and so there is a bit of inflexibility when it comes to things that are hardwired and already installed, and then you want to make some changes. And so that's a kind of another area that I think we're going to be able to focus on as well and help our customers through. And then really you're limited. One of the last points is really about monitoring, right? You really, when you wire things through I/O, you're monitoring the I/O point, right? I turn things on, I turn things off, right? You're looking for a feedback. You're seeing if the input is true or not true. With our new solution, you're going to be right down to the device level, right? This is going to allow us to put Ethernet directly to the device, where in a sense previously we're to an I/O point. So with all of those things, I think we're looking forward to kind of helping our customers solve some of those problems, and maybe problems they don't even think about today, but to try to make them more efficient, help them build panels faster, and with less problems. So this is a little bit on what the solution entails, right? So this is not just a single product, it's really a new infrastructure for the end cabinet. And it introduces a couple of new parts. And the first and foremost, and we'll talk about this a little bit, but it includes this thing called a gateway. As I shared it with you, that we're actually going to be taking Ethernet directly to components. And we can't certainly take full gigabyte, 100 megabaud Ethernet directly to components that cost, small dollars, because certainly they'd be outrageously priced, and who would buy them, right? So that's kind of where the single pair Ethernet comes into play. And so our solution will include a single cable design, and that's kind of important. So we're going to have a gateway, and we're going to introduce a new flat media that's going to allow us to connect these devices together. And we're going to be able to connect a total of 40 connections. So that's going to be a gateway plus 39 different devices that can attach to each of those gateways to my network. And there's some limits. 25 meters of cable, flat media cable per gateway. All right, so that's roughly about what, 75, 80 cable feet. Should handle most, small, medium sized panels out there. And the cool thing is we're introducing a new connector, right? So with that comes these new insulation displacement connectors that are going to allow you to connect those field devices without using specialized hardware, right? We're looking at things like standard pliers, standard channel lock to make that connection. All right, and the last thing that I really wanted to note is that we're really doing that for standard products. I mean, this is a means that, or this is an opportunity where we can actually connect this communication platform now to standard products off the shelf, right? So these are not custom configured, purchased separately products. These are going to be standard off the shelf contactors, off the shelf 800F operators. So I can talk a little bit more about what those products are and how we're going to connect to them here in just a moment. So I think I hit a little bit for the users today that again, this is going to allow us to be really truly end-to-end Ethernet, right? This is going to allow us to go directly from Ethernet straight through this new gateway. And yes, we're on a different media, but at the end of the day, it's Ethernet IP, and it's going to allow us to do that. Now, this is and the great news here, this is not a closed proprietary network. This is an open design that's approved by ODVA. This is ODVA's Ethernet IP in cabinet. We're going to be the first manufacturer to implement it, which is really cool. And so with that, we've created this infrastructure that obviously will be looking for others to join and to connect to and to communicate through. So that is really exciting. The cool news is we're also using standard tool sets. Since this is Ethernet, Shawn, we use all of our standard tools that we have today, like Logix Designer and Studio 5000. So it really helped cut down on the learning curve, right? Those control engineers, you don't have to learn a new thing just because we're launching out a new network, right? This is just Ethernet. If you've configured a drive, an HMI, you can configure a gateway on single pair. And so those are some really cool things that I'm really looking for. One of the things that, and I know maybe some of the users are just listening, but one of the things we noted here is 80% reduction in wiring time. So Shawn, you kind of hit it. You built systems before. I built a lot of systems, 6 minutes of wire. You start looking at those medium-sized systems, it truly is a significant amount of time that a customer can save. Something that they really need to look at.
Yeah, I can think of a panel full of contactors or starters. If you can just daisy chain with that ribbon cable, but across all of them, that is just a ton of. Or if you have a bunch of operators on your panel, you can just daisy chain all of them down. I mean, that is a huge saving.
Eliminate the discrete wire interface to the contact, to the connection point, replacing it with a single flat media connection. And again, you're right. It's what we're using is multi-drop topology. So what I'm introducing here is the gateway. That's really at the heart of this, right? And Ethernet, Shawn, right? You got the 100 megabaud gig, the teal cable. The gateway here will allow us to go from Ethernet IP, 100 megabyte or a gig, to what we call single pair, 10 megabaud. Now that single pair is going to be picked up inside of a single cable. And so the difference here is we're not just running two wires out communicating. We're running a 7 conductor flat media. And I think my next slide will probably show that a little bit more. But this is a new media. And within this media, we'll be running, again, the 10 megabaud single pair, plus we run 2 sets of power. And why 2 sets? 1 set for communications. So we run a network power to all the devices, right? That establishes my communications network.
Mhm.
And then my other power, we call it switch power. And that we're going to be using to energize coils. So and I'll kind of talk a little bit about with you what our initial offering is. But we're going to be focusing on, obviously, motor control. Let it out of the bag, but we're going to be focusing on motor control. So coils, right? We're going to turn coils on. So the switch power is going to be used for turning on contactor coils. We're also running in that same media. We run a select line. And the select line is actually used for topology finding, right? So every time we put a connector, every time we install a connection onto that flat media, we create a topology. We identify that there's a module at that spot or at that position. So as you said, you go from one device to another device to another device and so on, up to 39 devices. And the select line allows us to be that nodal positioner. And from there, we can create the topology. And
Now, I don't want to steal your thunder,
yeah,
but in the pre-show, we talked about something I thought was pretty important. For anybody who's familiar with legacy networks that have power lines, we were talking about the network power. And a lot of times we think, well, yeah, there's a Ethernet chip in the device that needs power, right? So it needs to get power from somewhere. But you were also telling me you can actually turn on the indicator on a pilot light using that network power. Is that correct?
yeah, that is correct. You're right. We're going to be one of the devices that we are going to connect to is a 800F, for our 22 millimeter panel operators. We'll have a communication module that will have a color changing LED. It has an RGB.
Mhm.
So for first time, we're going to be offering a RGB LED light source, runs strictly off of that network power, Shawn, which is kind of cool.
Nice.
Yeah. So 8 color choices. So our emphasis to start with is really going to be motor starting, right? So when you look inside of a panel, you've seen inside panels, the majority of control wiring comes from motor starters, right? That you got your coils, you got your auxes, you got your trip statuses, if it's your circuit breakers, you got all your operators on the door. You probably seen panels with this, I call it the spinal cord, right? You got a lot of wires and cables traveling between those locations. Not to say that there's other cables anywhere else, but that for us was probably a significant reason why we kind of started with the motor control as our first connection point. So we'll be attaching communication accessory to our 100E and 104E contactors. Those are our global AC contactors from 9 amps to 96 amps. So if you're a customer using standard across the line motor control using 100Es, we'll have a front mount accessory that'll snap on, no tools needed, and it'll allow us then to connect that flat media connection as one of those drops, right? As you said, and I think I'll throw a slide up here for your users, but that's kind of that front mount accessory, right? It's a simple over the top, click down, latch, done. And you'll have one for a standard non-reversing, and then you'll have one for a reverser, right? Because you got 2 contactors, so we sit on the forward and the reversing. The cool thing, Shawn, is that we pick up our auxiliary. So you don't need a contactor now, right? What's a motor starter? You got to have always an auxiliary contact, right? If I tell it to turn on, I need to actually run the auxiliary back to the PLC to say I'm actually on, right? So in this, we actually pick that auxiliary up through the communications. So just by having that module on the front of the device where we have the plunger inside, we can actually use that as our auxiliary. So that's pretty cool. We also have those accessories then that will snap onto our existing 800F and our latches. So today we've been selling 800F. It's the 22 millimeter, right? 22.5 millimeter panel operators, illuminated, not illuminated. They have a latch. This communication module or this accessory will latch or connect on the back of that standard latch, which is pretty cool. So a quick snap on. The other interesting thing is that we actually can connect two standard contacts adjacent to the COM module. So when we snap that COM module on the back, we can actually connect two additional standard contacts. So I don't know, customer might have an auxiliary circuit that he wants to pick up because maybe I have a hard switch and I want to just turn one other thing on or acknowledge something else. And so we could snap two contacts on, which is pretty cool. And then again, it's illuminated and non-illuminated, so pretty basic. So again, so that kind of completes the first attachment. Again, standard 100E, 104 contactors off the shelf, not custom, standard 800F, illuminated, non-illuminated, and standard latches, which is going to make life a little bit easier. And I love the idea that we're picking up an RGB. So it's that color changing, 8 colors, and we can have the advantage of this into the users listening is that you can begin to have clear lenses, right? A clear lens, and you can tell it that it's green or red or blue or amber or magenta or so you can change the color to it. And the cool thing is you can change it to multiple colors. So now you can have some skew reduction. So, because when you're designing a panel, Shawn, there's always like that one red button that you forgot to order, right? That dang red light that I needed to finish my panel up. And so now you can get some efficiencies where they can buy clear lens, use the RGB color, and ultimately they can drive some efficiencies and potentially even reduce the number of operators and indicators they need. So,
well, I know a lot of us too. When you had a limited budget, you were like, well, I'll use green for running and I'll blink green if it's a jam and I'll blink it really fast if it's something else. And so now you can go with colors. You could go.
That's
green,
cool.
Blue,
and you're right.
orange,
I should have.
Green. Yep.
I should have mentioned that, Shawn. We can be steady on, we can be illuminated, we can be dim. Oh, guess what? You could change the percentages of those as well. So, so if you want to dim a certain percentage or at night, so that there's going to be a lot of opportunity. Showing a video here, and I know maybe some of the users listening can't see that, but maybe they'll cue in later on. But here is a panel that kind of illustrates the flat media design. So when you look at this panel down in the lower left corner of that panel, you'll notice where the gateway is located. Leaving that gateway, you'll notice that flat media. And then just like we had talked about, there's 6 motor starters in this panel connected adjacent to one another. We have a couple reversers, the rest is non-reversing. And you'll notice that we go from module to module to module to module, right? You're running a little bit of a service loop between. Remember, this is a multi-drop topology. So guess what? I can actually take a module out for service without interrupting the rest of my network, right? So if you if for some reason you have to replace or change, simply lifting one out won't interrupt my network communications to the other devices. So that's pretty cool. I think then you'll kind of notice as the video moves, you'll see some door operators as well. So no big spinal cord, as I call it, spinal cord of wires. You really truly have just a single flat media cable that can continue that multi-drop connecting to those panel operators mounted on the enclosure.
Yeah, for those
Uh,
people listening, there's a bunch of operators in this one. I don't know. Do you have like 18 different operators in there or
uh,
more? But
I
there's a
think I
whole
used
bunch.
15 operators.
Hmm.
Probably.
And
I
it's
used
very
15
clean.
operators.
That's a
Um,
lot cleaner than, I mean, I can just at time wiring with standard operators and making sure all the bend radiuses are the same and it looks nice compared to this daisy chain, just taking the ribbon cable, clip, 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 and it just looks nice automatically. It
Sean,
looks like you have, go ahead.
any guess on how long it would take to connect? I think there's 22 nodes in here, I think, 15,
Mhm.
16, about 22 nodes. You know how long it took to connect the flat media to 22 nodes?
Tell me.
Less than 50 minutes.
I believe it. I believe it.
Less than 50 minutes, I was able to connect the flat media. Actually, it wasn't me. We had some integrators do this in our time studies, but
Now, I know you did the
that's
same
an
panel
amount.
hardwired. How long did it take to hardwire it?
Hardwired. Uh, Anywhere from, I would say on average, around 20 hours.
Wow, huge savings.
Yeah, hardwired 20 hours. And we were able to actually help reduce the panel size as well. It's kind of an offset, right? So if you can start to look at ways to streamline your panels and what you're putting in, well, you can look at either you can, add other things, combine things, or maybe ultimately shrink the panel, right? So there's
Yeah.
just a lot of opportunity depending on what the control system looks like or what their design looks like. But
Now I'm
you could
noticing
definitely,
some accessories in the panel. It's not just the ribbon cable and the connectors for each of the devices. Can you talk about some of the other accessories? I think you have like a joiner, a cap, and some other things.
oh, so actually, you're right. So in the, from the flat media,
Hmm.
you'll have a whole family of connectors. So
Okay.
we have a portfolio of connectors. So when you think of the flat media, you'll have a connector that connects at the gateway. You'll have a connector that connects at all of your end node modules. We also will have a connector device that allows us, in the event that, say, your flat media becomes damaged. Say they're in there doing something and they accidentally damage the flat media, we'll have a
Okay.
splice connector that'll allow you to join two flat medias together. So that'll be one member of the family. There is a terminator, right? So this is an electrical network. So at the end of that flat media, you're required to use a terminator connector. It looks very similar to the others. It's capped on one end. It applies the same way you install any other connectors. And then the last of the family will be a cap. The cap would used for two things. One is if you no longer want a node in service, you would remove the connector and you would apply a cap cover. And that essentially will remove that node connection from being seen within the network or even into the PLC, which is cool. So with the insulation displacement technology, if you install a connector, you can't remove it. Once it's removed, it actually physically pierces the cable, right? There's displacement and piercing within the same connection. So once you do the final crimp and take your pliers and crimp it, it can't be taken back off. And if you did, you'd have some holes in that. So you'd have to cut that section out anyway. So that's where the cap covers come in and allows you to kind of eliminate that node from service. So that's part of that. But what we're showing in this panel is probably maybe a little bit more traditional to family. You'll see motor starters, right? We connect, as we said, our communication module connects to the contactor, right? That's what we're controlling, this contactor. But contactors are contactors, and if you want to use them as a motor starter, we have products that will allow us to be like a motor protection circuit breaker. Our line of 140 products. That's a motor protection breaker. We have other devices like overloads, like E100 overloads, and again, those allow you to do different motor starter configurations, right? And our initial offering will allow us to have an interlock within the module that will allow us to interlock to devices like a circuit breaker or like an overload. So when those devices fail, we'll open the contactor. So those are some basic operations here. But and in the panel shot that you're seeing here, obviously there's power supplies and network switches and molded case breakers, and those are some of the traditional things that I think your customers are used to implementing in their designs. So
Yeah, I think when the listeners or viewers hear us say we're going to add 40 devices onto a single pair Ethernet, they're like, yeah, so we're not changing the switch. We're just adding one gateway. So we just need one port to get into the Ethernet IP if you're not going directly into the controller. And the
yes,
40 devices sit on the ribbon cable. And
yep,
they all live. I believe you had I know in the pre-show we saw a shot of the RS Logic Studio 5000, rather,
yeah,
Logic's designer, that
yeah,
shows that these all live as children under the gateway, almost like
yeah.
I/O cards underneath a remote I/O adapter or Ethernet IP adapter. So I think that's very interesting. Now, for those of you who might be wondering, it's a 1834 AENTR. Thank you for keeping the same nomenclature. So just like you
You're
would have an
welcome.
AENTR with anything else, all of your
Yep,
39 devices sit underneath that. In this case, we're seeing 800Fs and 100Es sitting underneath the
yeah.
gateway, which is in channel A1 of the compact logics.
Yep. Yep. We connected just exactly as you said, Shawn. We're connecting this platform to our latest generation controllers, the 5000 series controllers, 5380s, 5580s. This platform requires kind of that amount of horsepower, so it fits ideally to our latest gen controllers. V37, by the way,
That's
for your
important. Yep.
users. Yeah, very important. We'll need V37. That's where we start. And as you said, we add products to as you said, and I do have a screen up here now. If you see that, and for your users, this will fit into the I/O configuration tree, right? You'll add a gateway. When you add a gateway, it creates consider it kind of like a sub bus or a
Mhm.
subnet, a drop bus. And what you have, and that's how when you add those devices, you'll be adding devices under the gateway. The difference is each of those devices that you add have an IP address. You can assign an IP address and a name, just like you assign any other IP address. So your gateway has two sides. You'll have the full network side, the full TCP IP side, and then you'll have your single pair side or your flat media side. The that gateway bridge allows for you set your IP either hard set on the side of the gateway. You'll have a hard IP setting for the fourth octet, or you can be DHCP. You can set it in factory talk links, right? You can establish that. On the flat media side, IPs are 192.168, 1.1 through 40. And in the gateway always being 1.1.
Now, are those addresses assigned based on the physical location on the ribbon cable?
No, actually, they're independent of that. So,
Oh, okay.
so you do not need to be consecutive on your IPs, right? You can certainly make a network that's IP 1.1, 1.2, 1.3, all the way to 40. But some customers will want to probably, maybe they want, motor starters being in their 20s or something. I don't know, not 20s.
No, I
It'll be
could see
some,
that. Definitely,
yeah.
if
And
you have
so,
starters and operators, you may want to separate them.
yeah,
Do one is 10 through 20 and one is 30 through 40 or whatever. But yeah, I could
exactly.
definitely that's good to have the flexibility.
Yeah, so it doesn't mean that IPs are linear on the media stream. So
Hmm.
it really controls. You're controlling it to an IP, but
Hmm.
that doesn't mean it's the position number. So that can be different. And so the gateway helps us do that, where we'll actually have something called a reference topology and an actual topology. So it allows us to kind of move those devices to match topologies, really. And that probably gets a little bit hard on a podcast to show you, but we have the ability to do that. and which is pretty cool. But at the end of the day, you can control directly down to that device. If I wanted to go into my tree and I want to go all the way down and I want to connect to a 800F push button that's at IP address 192.168.1.5, I can do that. I can control it through the controller. I can see all of its data bits, right? The controller bits. I get inputs, outputs, config, much like you're used to seeing on any other device. So that's, and again, we're doing all this through, Logix Designer, Studio 5000. So we're hoping that that's going to certainly help cut down on significant learning. And again, we're treating this as just an extension to Ethernet IP, which is what it is, right? It's Ethernet from end to end now, all the way down to your push buttons on the door. When you start kind of thinking about the outcomes, right? We covered a lot of ground, right? We kind of talked about a lot of things about the solution and how it might work and what you see. But really for customers and the customers listening, you really look at a few different things. One, we can look at reducing wiring time. We talked about that as being an 80% less savings or up to 80% savings, depending on what your configuration is. We talked about having the opportunity to reduce panel size. And so that's a huge outcome. So, if you're looking to try to save space, time, labor, great opportunity to kind of go seek and try this new solution. We talk about how simple it is, right? We talk about simplicity. We talk about eliminating hundreds of wires potentially. We talk about eliminating the actual screw terminations, and we talk about how easy it would be to just quickly create a multi-drop connection within seconds to connect the connector and to jump to another connector and to another connector. And again, we see this on some of our time studies, some of the integrators that have already had an opportunity to try this. It's significantly fast, and using those new IDC connectors certainly help us do that. We talk about sustainability. That's huge. We talk about reducing, right? We talk about what are we reducing? We're reducing copper. We start talking about taking physical wires out of a control panel, out of a control system. We start reducing copper, plastic. We could physically start reducing panel sizes, metal, weight. If your customers are shipping, enclosures and systems, I mean, everything helps, right? And so I think so those are some huge outcomes. And then let alone it's the insights to data, right? So we improve the ability to see these devices. We can now see these devices in somewhat real time, right? We can actually click and go to a device directly. We're not going to an I/O program and checking to see if the output is on, right? Because we don't really know if the device is really truly on. But now we're truly at the end device, right? We're sitting on the end device, meaning the button, the starter, the contactor. We know its status. We know the condition, and those are some huge outcomes that I think we can help our customers with. So we're pretty excited. I think a couple of things. One important thing that maybe I didn't pick up on is predictive maintenance, and I think that's a huge piece as well. That the system will now keep track of number of hours and number of operations, so that data will be within its device. And so, today some of that's done by sticky notes in the machine, and the last time it was changed. And so, now it's simply, some of that data is monitored, and data's visible within its add-on profile. All these devices use add-on profiles, and I can go into the add-on profile. I can see my elapsed time, how many operations, what's my remaining life, things like that. So those are some pretty neat things coming. So again, we're excited about it. A lot of opportunity out there, I think, with our customers to help streamline their controls, help consider opportunities to maybe save them time, save them money, maybe help knowing that they struggle too with labor and resources and trying to do more, right? They're trying to always produce more systems with less and trying to get machines out the door. So we think that this position or this product or solution can certainly help us do that.
Especially since, with today's kids growing up with touch screens and handhelds and smartphones, there's not as many of them who are going out there and getting into, becoming a technician, electrician who wires panels all day. It's harder to
Yeah.
find those people. And
You're
so
right,
if you
Shawn.
can make it smarter and more intelligent and quicker, then, some of these people who have been wiring panels for their whole life can retire and we can still have control panels being made.
Where was this 20 years ago, Shawn? I could have
Oh,
used
I
this
know.
now.
I know. I know. Yep.
It is that is interesting. You are exactly right. I think we're accommodating to kind of a new age,
Hmm.
and you're right. A lot of that, complex wiring and control circuits. I mean, some of that can be replaced simply by connecting to it and turning things on and off, and treating it like a lot of our other, Ethernet, connectivity. So I'm really excited about it, really am. And it is available. We're launched, and I would encourage all of our listeners today to go learn more. You'll find that up on our Rockwell Automation website. So I would have them visit there and see what the possibilities are.
Yeah, and we're going to include that link in the description so you guys don't have to write that down. You can just click on it. It should be everywhere in the show notes. So if you're listening, there's a link that goes directly to the page at rockwellautomation.com that talks about this, infrastructure Ethernet network that we just talked about, this in-cabinet Ethernet IP solution. So check it out. I think it looks just really cool, and it's exciting how much time, and I'm sure a lot of you out there who are OEMs or who are integrators, you can see the value of this as well because it can just let you do more, right? And so, Kelly, thank you for coming on and talking about this and sharing this with the audience. Congratulations on launching it this week. It's exciting. And I hope you guys, everybody who's listening, we'd love to get your feedback. Comment whether you're on YouTube or iTunes or Spotify or somewhere else. I know we go so many places. Please leave your comments. You're going to like this. You're going to check it out, and let us know. But with that, Kelly, was there anything else you wanted to cover today?
I think we covered a lot of ground. I'm just excited as well to get this product launched. It's been a big development here at Rockwell, and just really excited to see what our customers. We've been driving a lot of interest over the last few years at various shows and our automation fairs, and I'm just looking forward to getting it into the plants and letting our customers start to implement it. So that is great, Shawn. Thank you. Thank you for the opportunity, and great talking to you as always.
Well, I hope you guys enjoyed that episode. I want to thank Kelly for coming on the show and doing a pre-show with me and then filming the actual show we did. And I really appreciate him and all the folks over at Rockwell Automation for making this happen. You may have noticed there was no ads in this episode. That's right, because Rockwell Automation sponsored it to keep it ad-free. So I really appreciate them doing that. And I hope someday I can get some of that new product to put up on the wall there and test out and do some more videos with you. But with that said, I always appreciate your comments. I try to check them every day. So if you have any comments, thoughts, or opinions on this, please let me know. There is also a bonus after show just for members. So if you're a member, please check that out. Some really cool stuff in there I think you'll want to see. And with that, I just want to thank you all again for tuning in this week. I want to wish you all good health and happiness. And until next time, my friends, peace.